things to be recorded.
Brent.
So we're going to talk about chapter 4, which is structured analysis. Let me share my screen here. And so we completed the planning phase, topics, and then we moved on to the analysis phase related topic last week, which was requirements engineering. And now we're gonna talk about another topic in the same analysis phase, which is structured analysis, okay? In fact, I thought that was chapter 3, but I'm wrong. I think it was chapter 4 we covered last week, and it's chapter 5 we're going to talk about this week, which is good. I'm happy. This is data process modeling, which is, also called structured analysis, okay? So just so you know, there are, broadly speaking, 2 types of analysis as far as this, course is concerned. Data process modeling, which we're going to talk about today, and also the object-oriented modeling, which is for next week, okay? So we're going to talk about what's the difference between logical physical model. And different types of artifacts are produced, as part of the analysis phase, including the, they call it business requirements document, functional requirements document, functional decomposition diagram, data flow diagram, several artifacts, right? So we're going to talk about primarily, the functional decomposition diagram and also the data flow diagram in this chapter. And as far as the data flow diagram, there are different, symbols involved in creating those diagrams, basically 4. A lot of rules involved in, using those symbols. Talk about what those guidelines are, and different types of data flow diagrams too. Context, diagram 0, diagram 1, different levels, right? Starting from the higher level, you can go as much deep as you can. There is no technically, limitation as to how much levels, but, practically speaking, probably, at the most, you may go 3 to 5 levels, right? Unless it's a very complex process that you need to maybe, go further to explain the different, sub-processes and things like that. Leveling, balancing, and technique we follow as part of this, data flow diagram creation. It's good to keep in mind as it's not an exact science, right? So, but also if you follow the guidelines, the techniques, the output will be what? Good quality that everybody can understand, okay? And using that, we are going to talk about how data dictionary created, okay? So what is a data dictionary? Talked about that a little bit maybe in our chapter on database design. That was part of ITM 5000 if you've taken it, but if not, we're going to talk more about that in this chapter as well as data design too. Process description tools. So as you can imagine, every system is nothing but represents a lot of business process followed by that team that we're trying to build within that system. So what are the different tools we're going to use to describe, the different processes and try to come up with some kind of a modular design that is easy to understand and also implement, right? Logical model, physical model. What is a logical model? It's just something we put on paper, right? And it talks about, the what type of questions. What does the system have to do? It doesn't exactly talk about how we have to implement, what technology, what language, what infrastructure. Just talks about what does the system do, right? So, and doesn't talk about how, right? That's the main difference between the logical and the physical. The physical talks about how will it be done, how will the system be constructed. And as part of the analysis phase, we're mostly focused on the logical, right? But kind of we transition from the logical into the physical, by end of this analysis phase. So that said, logical model, right? The system analyst, as part of their analysis and, the work that they're doing for that project, they can be doing a lot of things, right? Attending those JAD sessions, or if they're doing RAD, that's fine. You can attend those. If it's a process, then, there's certain things done differently. So they could be looking at the physical-logical model of the existing system that they're trying to enhance, right? It's not always building a new system. If it's an existing system, we can always try to add new features, or maybe fix some major problems. And also, as part of this, they can be constructing the logical, model, right, of the system as well, right? And towards the end, maybe, some people may come up even with the physical model, depending on, the skill, the experience of the, system analyst, the team, right? So that's kind of the high-level picture of this chapter, right? So system analysts, what do they do? They're doing a lot of things, but primarily this phase, what they do is they're using all these graphical techniques, be it the DFD, the functional decomposition, other type of diagrams. It could be business process, modeling diagrams, some cases flow charts. That's why I think I gave you guys that assignment, right? So that said, one of the primary artifact of the document that they will produce is what is called data flow diagram. So that's DFD is the short term for that. And it uses about 4 symbols that shows how the system is what? Pretty much what are the different processes within the system? What are the external system that our system is, connecting to or interfacing with? And the flow of the data, what are the inputs, what are the outputs, inputs to each process, what's the output from each process? And showing, pretty much, how the data is moving through that information system, right? The key things that you will not see is any kind of logic. That process symbol, sort of a black box. All we know is some input going in, there is some output, okay? And doesn't talk about how that input is transforming into the output, okay? In some cases, if you have different levels, it can also talk about within each process, what are the different steps, right? Which is sub-process within each process. So symbol-wise, I think let's try to maybe zoom in a little bit. Okay, that's better. Here are 4 different symbols, right? That represents process, data, flow, data store, and entity. So depending on, the choice of the analyst, they could be using gain SAR, source and symbol, which is all of these, or they can be using the Jordan symbol, okay? So the only difference is pretty much, as it relates to process, in one, it's a rectangle, the other one is a circle. And, as far as the data flow, it's the same symbol between the two. Data store-wise, in the gain source, they're talking about using this symbol for data store, whereas in Yodan, it's just two parallel lines, right? Kind of. And external system represented as a 3D box, it's a 2D, right? So what does the process symbol do? Receiving inputs. It could be one input, it could be, several inputs, right? And it is generating an output. But within that process symbol, what we should know is there is some kind of a business logic, some kind of a code that transforms that input into that output data, right? So every process needs to have some kind of a specific function, which is what is that exact step going to do, and a name too, right? That identifies that function. So that's why they're saying in DFT, the process symbol is called what? A black box. Means we don't know how exactly it's doing that transformation. So next, moving on to the next symbol, which is what's called a data flow, okay? And here we talk about, what is the direction of the flow of the data in that process, right? As you can tell, an arrow is representative of the direction, right? Some of the correct ways of using that, data flow symbol with the process. One input can result in a, single output. Sometimes, one input can result in two outputs, right? Two inputs can result in one output, and you can also have a chaining of the different process, right? One input results in another output, which becomes the input for another process, right? So that's kind of a data flow. And what are the different ways you can use that symbol incorrectly, right? And you should try to avoid. It could be who knows, an exam question too, right? Hey, is this a correct, data flow, diagram representation or not, right? So here they're talking about different ways you can use these symbols incorrectly. One is what's called spontaneous generation, where this is an example where there is no input, but there is two outputs. How is that possible, right? That's spontaneous. That's the wrong way of using these symbols. Black hole, where you have two inputs going in, but no output at all, then what's that process doing? It's the question, right? What's the purpose of that process? To be avoided. Gray hole is, we're sending one input, but the output that's coming is completely unrelated, right? I'm sending a date of birth and I'm getting what? Final grade. How is that possible, right? The thing we have to avoid, right? And let's see, moving on to from data flow to data store, okay? So data store symbol does what? Talks about, every process after the transformation of the data, sometimes you need to store the data somewhere, right? So this is representative of that data store. In any given system, you have multiple tables, right? And this is, in other words, just maybe a table or a group of tables, right? So that's a data store. But even in this case, they're saying DFT does not show the details of that data store. It doesn't show details about, what is the table name or what are the different columns and all of the, data types and all those things, right? So all of that information they're saying, about the data store is stored in what? Something called, you can find it in something called a data dictionary, right? The different fields and the data type and the alternate names and where it's used, domain values, all those things are part of what's called a data dictionary, right? It's a very detailed level information about the data store, be it database, the underlying tables and columns, whatever. So a data store must be connected to a process. That's another rule, right? With the data flow. So do we have an example here, right? Maybe here is what we're saying, but we'll just keep that in mind. It must be connected to a process with the data flow, so without the data flow, you cannot physically connect directly a data store to a process is what they're saying. So entity talks about, some of the external systems that our system can interface with, it's what's called a entity symbol, that 3D box we saw earlier. Related to the entities, what DFT shows only external entities. So there may be so many systems in a company, but our system may not interact with all of the systems. We only show the systems that our system is interacting with in that DFT. It could be 2, it could be 4, right? But not the hundreds of systems we have in the company. And these are the systems that our system is receiving input from or sending output to, right? So they're also called what? Terminators. They can be either origin of data or they could be what? Destination of data. In other words, source or sink, So some of the correct ways to combine all of that, the entity, process, and data flow, right? Just a way, right? You have an external entity called customer sending payment data to our process called what? Apply payment. That may have several underlying process. Same thing with here. Our prepare deposit process sending data to a bank, right? In some cases, you have an internal process sending data to an external, which in turn sends, information back to our internal, which is possible, right? Some of the incorrect ways of using the symbol, right? Where an external is sending data directly to another external, we shouldn't be showing that as part of our DFT, right? External sending data directly to a data store, that's not allowed. It has to come through some kind of an internal process, right? And same thing, our data store sending data directly to a external, that's not allowed. It has to have some kind of intermediate process. Those are some of the rules, and this kind of summarizes, all of those rules, right? The do's and the don'ts, okay? So other things, right? Drawing the data flow. So it's one of the good way, to represent all of that information, the team has collected, from their fact-finding mission, right? Rather than everything being, verbal or in plain text, you can use these type of diagrams to clearly illustrate, all of that information that's been gathered about our system, our process within that system. So as a system analyst, they need to make sure, if they're not experts at this, they need to review those guidelines to make sure they avoid the mistakes, right? So let's see here, drawing DFT, applying the guidelines, creating. So if you want to, you can, try to, create your own DFT practice so that all of those rules kind of, is firmly embedded in your mind, right? Let's see, what are the guidelines? Just kind of summarizing all of the different guidelines of the data flow diagram, right? Drawing the context diagram so it fits in one page. Exactly, right? That flow chart I talked about, right? One of the flow chart, you just had it in multiple pages. It might be happening, but there, what you would see is if you go look up the flow chart symbol, there will be a terminator symbol, right? Or some kind of a symbol that you use to terminate. And then the next page, you will use a similar symbol to indicate that, hey, we stopped in page 1, but now we are continuing, right? So in the case of DFT, they want to make sure that you try to fit everything in one page. If not, you can use multiple, but there's a way you transition that, right? Use the name of the information system, as the process name in this one type of diagram called a context diagram, right? That's the highest level DFD you can think of, right? So here you have your system, which is represented as a process with the name, and it's talking to other external system, right? And that's what's called a context diagram. And make sure that every symbol has a unique name, right? No crossing of lines. Sometimes things get complicated. Cross means you should not have two lines cutting each other, but there's a way you can, use some kind of an arc to say, hey, I'm just, jumping over this line, but it's not by any way intersecting, right? Which can lead to some confusion. We talked about providing unique name, obviously, and number too, right? So that when we're talking about it, refer to process 1.1, right? Because if we say apply payment process, then it's hard to kind of pinpoint in that DFD where it is. But if you say number, then people can easily get to it, right? Make sure the model is accurate means following all of the rules and meets the needs of the users. That's where, by showing this, we are trying to, again, confirm. We talked about validation and verification, right? Requirements engineering, and that's what it is. So this is kind of an example of a context diagram, which is kind of the first step in generating or creating a data flow diagram, right? So you have your main system represented as a process. And how do you know it's a context diagram? In a couple of ways. One is that process has a number 0, right? Given. That's what means a context diagram. And there's only one process, which is the name of the system. And then it's talking to several others, external system, right? Customer, warehouse, accounting, bank, sales rep, or the external system our order system is talking to, right? Or interfacing with is more of a technical term, or integrating with. And that's showing all of the flow of data, right? Because that's what is called a data flow symbol, right? Now the question to ask is, between here and here, can I have a data store, right? Maybe not, because if you have a data store here, then it cannot send data directly to entity. Then it has to be another process, right? Between that. So those are the ways you kind of try to remember all of the rules, right? Now, next is what? Diagram 0. That's the next level of a data flow diagram. Context, and then diagram 0, which talks about what are all the different processes within that system, which are given the numbers 1, 2, 3, right? This case, fill order, create invoice, apply payment, which may be talking to, these different systems, right? And in some cases, storing data within an internal data store and all of the different, direction of the data flow, right? It's a little bit more detailed, right, than a context diagram. That's kind of a diagram 0, but as you can imagine, now I can have a diagram 1 that talks about within the create invoice, what are the different steps. And those will be numbered what? Maybe 2.1, 2.2, 2.3. Same thing with fill order, right? 1.1, 1.2, 1.3. And that's an example, right, of the second level, right? And they're talking about leveling and balancing techniques. If they are used, then it will all come together, right, as you go to the different levels. So here we're talking about verify order has 2 other steps: prepare, reject invoice, and assemble, right? Which is part of what? Fill order process, right? Has 3 different steps. And verify order as the name says, make sure that all of the information in that order is accurate, right? Before, if it is, then you reject the order, right? If everything is correct, you accept the order and put that order together, right? Send it to the warehouse, update the inventory, right? And all those things, which is part of that process, right? The different data store, we have product store, we have customers. And, as you can imagine, you can have so many different, type of data stores, right? Let's see, leveling and balancing is sometimes you may not be able to fit everything in one page, and that's where you have to use those techniques. So where, okay, I'm using this in the next page, but if I go to the previous page, those arrows should all line up, right? And not confuse the users, right? So they're saying, this diagram does not show the symbols that connect to the data flow entering or leaving fill order, right? In the context, right? That's, lower level DFD. And this is where we're talking about kind of a exploding view of each of the process. Apply, if you kind of explode that, that'll have several sub-process, but then you have to see that leveling and balancing, if you apply, then those arrows all line up, right? Lines up with this one, exactly with, we talk about, maybe I should zoom in a little bit. Makes sense. Here, we're talking about apply payment, right? We have payment flow coming in, commission going out, invoice detail, right? But now I am exploding that into 3 or 4 different processes. Here I'm seeing the payment is coming to one of the sub-process, right? And commission, where is the commission going to? In this here, we're seeing commission is going to sales rep, which is matching up here, right? And then we're talking about invoice detail, that is part of, this one. So at the end of the day, it's all coming together, right? And cash payment receipt happening here. So that's the kind of the leveling balancing technique, as you go from the lower to the higher, those arrows should kind of match up, right? Same thing from higher to lower, it should all come together. Let's see, this is another example of, this is maybe what, context diagram or diagram 0, right? This is diagram 0 because of the number, right? Context would have number 0. So there is one process getting 2 inputs from 2 different external entities, but sending output to 2 external entities, right? But now if I can explode this into sub-process, this is what it will look like, level 2. And we talk about 3 sub-process, its own data store, but those arrows all match up, right? One case, this arrow is going to process 1, right, of the main process, and arrow going to process 3, right, from process 3. So that's how that leveling and balancing techniques come into play, right? Because not always the high level diagram convey enough detail. Then you have to use, multiple levels, right? So that said, data dictionary, moving on. Any questions on DFD before we move to the next set of slides? Which is a very important concept as far as data process, is concerned, right? So moving on to data dictionary, nothing but what? It's kind of a metadata of all of the information stored in our database, right? It's kind of a storehouse of all the information about information we're storing in a system, right? So why would it be something that, system analysts would need to use, right? If it's an existing system, then they can use that data dictionary to understand, how the actual data is modeled within the existing system. Understand the different, tables and columns within each table, how each table is related to other tables, right? How kind of information is organized within that system, right? That's a very useful tool. That's part of every major database product, right? Describes all of the data elements and meaningful combination, right? Maybe there is one field, that's used in multiple, processes, or, one table that is updated by multiple processes. So that's all of that information is available in that data store. Data element, nothing but what? Other word, it's called a field within a table, right? It's kind of the smallest piece of data you can represent or have within a table, right? Or within an information system. And when you combine small pieces of data that are related to each other, that forms what's called a record, right? Meaningful combination of related elements, which is in the case of a student record, first name and last name, they're all like, individual data elements, but if you combine first name, last name, email, student ID, all of that, it becomes what's called a student record, meaningful combination. And they can use all kinds of tools, right? As part of this data process modeling. And then if you're using a sophisticated tool like a CASE tool, right? Computer-aided software engineering tool, it has built within it, framework to support this type of data process modeling. You can use that to create maybe a DFT diagram, a functional decomposition, maybe a flow chart, right? And it'll enforce a lot of the rules too. When you're trying to create a DFT, if you're using some incorrect combinations, it's going to maybe alert you that this is not correct, right? So why do analysts use CASE tools? Just to simplify their task, because they're going to be doing so many things within a project, trying to create so many artifacts, that they cannot use several tools, but something that's built within one software, right? Sort of simplifies that task of doing your data process modeling. Moving on from that, we talked about data dictionary, documenting. So as a system analyst, you may have to understand the existing data structure, or based on your discussion, maybe there is a need for creating a new, entity or a, table that has several different data elements, right, or fields. So that can be documented, as part of the, process here. So the objective is what? Providing as much of clear and concise information, right, about that, the process that's part of that system, right, that makes up that system. And what are the things that you can see within a data dictionary, right? Lots and lots of information, as you can imagine. Talked about data element, and every element may or may not, right? Alternate name, type and length, default value, if there is something true or false. Some cases false is a default, some cases 0. What are the different values that are accepted? Sometimes it's a range, it can be 0 to 100 if it's age, or, in some case, maybe, 1 to 10 if it has to do with something to do with the ranking. Sources, what is the source of that information? What application is, updating that data, right? Security means who has access, who are allowed to do what, right? Some people just can read, some people can update and delete. Description comments, something more detailed, because several years after the system is developed, if somebody's looking at it, they should still be able to understand, right? That's the whole purpose of documenting. To make sure that it's not about that during that project, even long after somebody is looking at it, they should be able to clearly understand and not having to call somebody who may or may not be working, right, in that team, in that company. So that's where that clarity and conciseness needs to be there. Alternate names, origin, we talked about that, what is the origin, what is the destination, where is it going to? Volume, frequency, how often is this information updated? And what's the volume? How many records are we creating in that table, right? That will be helpful when it comes to data design, right? Making sure our data model is optimal so that the system can perform in a very optimal way. We talked about data store symbol name, which is nothing but name of the table, right? Documenting the process. So in this case, it's talking about, which process would be updating information, right? Or using the information from this particular, entity or table, whatever, right? And you can just give a number, right? That will map to what? The DFT diagram. What's the process that's updating? What's the number? What's the name of the process? The description and all of that. We talked about input data flow, output, some cases the table may be used as the final destination of data. Sometimes the data in the table may be used for a certain process, right? Those are all the different ways this data dictionary, as you can see, there are like 10, 15 slides just on this particular topic, right? What other things can I think of? Record, data structure, name. So these are things that, if you remember, we talked about different roles within IT department. Within maybe the database team, we have several roles: the database administrator, the data administrator, right? Both of them can find good amount of information in this data dictionary, right? They are the people who will typically, along with maybe system analyst, request these type of reports, right? Hey, can you give me the data dictionary of our inventory management system or our order management system, or payroll system? And once you get that report, it talks in detail, about all of the different elements, entities and data elements and everything, right? Talks about the data flow, and everything is up to that analyst. If they have filled that information out, then it will be there, right? It's not going to automatically make it. But again, these case tools, there are some tools that are powerful enough that once you create the data flow diagram, maybe, you can use that as an input to generate those tables, right? Some case, that may be possible too. Characteristics. And moving on from data dictionary to modular design. Most of the system these days, that have been developed in the last 25 years, if you want to call it, the focus has been on what? Trying to build the system in a modular fashion, right? Modular means made up of several components, each component responsible for one particular thing, right? And that thing only, so that it makes it easier to maintain the system, enhance it, even, for example, development too, right? Versus everything being in one monolith, or a monolithic system. So with the modular design, you're documenting that, the functionality of every module, right? What is the business process that is part of that particular module? Steps within that process, all of those you can document, right? There may be the payment module, there may be the, order fulfillment module, there may be the order processing module or accepting module, all those things, right? So you're representing what? All of that process step and business logic in either simple English, right? Structured, make it easy to understand. Some cases you may use other type of, techniques like decision tables and decision tree, right? We probably have an example of a decision table and tree later on, right, in this slide. Because sometimes representing all the complex business logic in pure English is difficult. That's why we take the help of, these decision tables and trees, right? So we're also talking about a little bit about the object-oriented, right? Modeling as well. If you are doing modular design, what is more preferred is object-oriented. It's built for modular design, but even in the case of data process, you can do the same modular too, right? So object-oriented, which is our next chapter, right? It's combining what? The data process that's part of this chapter, but representing everything in terms of real world objects, right? That you and I can visualize better, right? And the interaction between those objects, all of those. Part of it, object-oriented, right? And within the object-oriented world, your process is typically called by what? Another term called method. Again, it's kind of a technical thing, which is part of object-oriented. You have class, you have methods, you have, data types and all those things, right? Which is something we'll cover more in our next chapter. So as part of that modular design, you can come up with, several modules, and you can say, sorry, some of those modules, maybe operating in sequence. In some modules, you will have things like selection going on. There may be several choices. I'm selecting one. So it is part of that, if you have done programming, if then else, type of thing going on. Some case iteration, right? Iteration, nothing but, executing the same step several times, right? The for next loop in programming. So structured English has been used for a long time, right? But the reason they call it structured is it should not be like blobs of text, but something broken down, by maybe requirements, maybe by process, by sub-process, so that it's easy to follow, right? And making sure that, you're able to describe all of that logical process in a clear and concise way, right? Using all of these different techniques, right? You may be sometimes representing something that's a sequence of steps. Some kinds that may be, involving some selection, sometimes iteration, right? So all of those things, you need to have some kind of techniques to represent that. Using indentation, again, not everything in a big blob of text, using indentation, using bullet points, all of that to represent, the things we see in the DFT in a more clear way, right? Limited vocabulary means don't use something very technical, use language that's easy for everybody to follow, okay? So we talked about decision tables. What does those mean, right? These are the tables that you use to what? Represent any kind of a business logic, right? Every business logic will have so many different combination of inputs, which will result in what? Several different outcomes, right? So that's what this decision table is good at, showing. And one of the things to remember is the number of rules double each time a condition is added, right? If you have two conditions, right, then the outcomes is going to be 2, right? But if you add another condition, make it 3, then the outcome is not, 6, but in fact it becomes, or 3, but it becomes 4, right? Just by adding, it doubles the condition. So adding 3 means instead of 4, it becomes 6, right? Outcome. So the key thing with the decision table is it's the best way to describe what complex set of conditions. Think about representing the business logic related to insurance, vehicle insurance. You probably have purchased vehicle insurance. So many things involved in coming up with a premium, right? To create that policy. So that's how you represent these complex set of conditions. So that's an example, right? We're talking about these are all the conditions and these are all the outcomes. So they're saying that pre-condition, right? Preferred customer ordered, 1,000 or more, use a charge card, right? So those are the 3 conditions. And if you have 3, you have 8 outcomes, 2 to the power of 3, right? And depending on whether it's a preferred customer, yes, no, ordered $1,000 or more, yes, no, using a charge card, right? So think about if it's a preferred customer, ordered $1,000 or more, use a charge card means what? They qualify for 5% discount and additional 5%, right? Those are the outcomes. And when these are the combinations of the different conditions, right? But if I'm a preferred customer, ordered more than 1,000, did not use a charge card, right? That case, what? I'm only getting 5% discount. I'm not getting all of these other things, right? And if I'm just a preferred customer and if I didn't order more than 1,000, I'm not even worried if I'm using a charge card or not, right? Doesn't apply. In that case, I just get a $25 bonus coupon, right? It's not a $25 off in that order, but coupon for the next time, right? And same thing here. Yeah, why no? What's the difference here, right? If you look at it, preferred customer, yes. Ordered, no. Did not use a charge card. It's another 4th outcome, right? They're saying. So you have $25 bonus coupon. If I'm not a preferred customer, then doesn't matter, whether I ordered more than 1,000, less than 1,000, or use a charge card. I'm just gonna get a flat $5 bonus coupon, right? So all of the different outcomes. So here the difference is, yeah, no, both seem same, but I may have used a charge card, yes. I may not have used card. The reason putting a dash here is you could have put yes and a no. But here we are saying it just doesn't matter. We're not even going to evaluate that condition, right? And that's why they have a dash here, right? That's a decision table. Think about representing this in just structured English. It's going to be very difficult, right? That's one of the tools that system analysts, if they're skilled, they would use, right? And makes it easy for everybody to follow. And if they follow, then they may ask questions that may lead to further, expansion of that rule or correction, right? The next thing is decision tree, which is similar to a table, but it just has that tree structure to it, right? And you can represent the same thing that you saw in the previous slide in kind of a tree format. Maybe some people follow this easier, right? And this is typically done for, the management to review this, but also mostly for developers, right? They're the ones who are going to be coding these rules, whatever language, be it Java, .NET, JavaScript, or whatever, right? So that is the reason why we use these powerful tools, right? In your case, you can ask, maybe you should answer in the chat, which one would you use if you are a system analyst in a project? Would you use a decision table or a decision tree? Go ahead and put it in your chat. Let's see what the, most preferential, way of representing these complex rules, right? So we're almost at the end of the chapter. This is kind of a short slide deck, but again, a lot of powerful information. And what I'm going to do is maybe once we come back from our break, we are going to maybe pick a couple of case in point, right, from this chapter, and we're going to talk about that. And then shortly after, we're going to have our, quiz, which I think I scheduled it for 7:30. That's when your quiz will start, okay? And we will talk about that when we come back from break. So any question before we leave for the break? And make sure you kind of, in the chat, put your preference, right? Would I use a decision table or a tree, right? To represent a complex, business rule, okay? So any questions before we take a break and come back to talk about some of the, practical applications of this concept, and then your quiz. Okay. Well, if there are no questions, then let's take a 15-minute break, almost, right? Come back at 7:10, okay? So see you back 7:10, and there have been people waiting. So folks who joined just now, we are going to be coming back after a 15-minute break at 7:10, and we'll talk about, some of the case in point discussions from the book, and then we'll have our quiz, okay? So see you back in 15. Hey, welcome back. Hopefully all can hear me. So we're going to talk about a couple of case in points, one from chapter 4, which is requirements engineering, right? So this is case in point 4.1, North Hills College. So North Hills College has decided to implement a new registration system. Think about that, right? You all studying in college, so may be able to easily understand that will allow students to register online as well as in person. As an IT manager, you decide to set up a JAD session, right? To help define the requirements for the new system, right? IT manager does not know all the requirement. That's why we set up those JAD sessions. So North Hills organization is fairly typical with administrative staff that includes a registrar, a student support and services team, a business office, IT group, number of academic departments. Those are all the different departments within that, university. So you have idea about all of this information, maybe from organization chart or whatever, right? So using this information, you start to work on a plan to carry out the JAD session. Means what? Who are all the people I need to include, right? Because these JAD sessions are time consuming, expensive. So you want to make sure you include all of the right people. So who would you invite to the session and why? What would be your agenda, right? You need to have a solid agenda for all of these sessions, right? And what would take place at each stage of the session. If it's a 1 day session, then it's usually split up into maybe, 4 sessions. If it's a 1 week, maybe, think about maybe 20 sessions. So what would be the agenda for each session? What are you trying to accomplish? So that said, so think about, a lot of the things from chapter 4, right? And this is where, I know this being week 4, next week is midterm. So I don't want to give additional assignment. You already have one from last week that you complete and, turn in by Friday. So that's case point 4.1. Very interesting. And then we talk about one case in point from today's topic, which is on data and process modeling. Okay. And let's pick one which is talking about case in point 5.1, Big Ten University, another university. You're the IT director at Big Ten University, a part of a training or as part of a training program, you decide to draw a DFD that includes some obvious mistakes to see whether your newly hired analyst can find them. So in the book, they're talking about a DFD, right? Which is a diagram 0. So you have to kind of look at it and try to explain, what are all the problems within the DFD that the director is trying to check. So think about attending an interview, right? For an analyst job, maybe this is a question that might come up. They may show a DFD and ask you to point out some of the mistakes, right? So as you try to read more of the finer aspects of each topic, some of those concepts will, be more clearer to you, and then you'll be able to, handle these type of questions. That's 5.1. We can do 5.2 as well, right? That's why this book is so nice. Hopefully, you all have a copy. And then you can go back and look at these. So we talked about 5.1 and then let's look at 5.2, Rock Solid Outfitters, some kind of a apparel company. marketing director at Rock Solid, a medium-sized supplier of outdoor climbing camping gear, has asked the IT manager to develop a special web-based promotion, right? So Rock Solid will be providing free shipping for any customer who either completes an online survey form or signs up for the newsletter. Additionally, if a company, customer completes the survey, signs up for the newsletter, Rock Solid will provide a $10 merchandise credit for orders of 100 or more. So as an IT manager, you've been asked to develop the decision table, or it could be a tree, right? That will reflect all of those rules that they've been asked to implement, right? That'll be easy, that you can, in a decision table or tree format, you can share it with the programmer to code, right? So you have to show all the possibilities of, all the conditions and the outcomes, right? So to simplify the results, to eliminate any combination that would be unrealistic or redundant, how will you proceed? So that's another case in point, okay? So go through that. In fact, now that we're talking, you have the option of either completing that, what do you call? The flow chart we discussed last week about how you, from your bachelor's program, what are all the things you did to, arrive in the United States and join Webster, right? All of the different steps. But again, as a team, you need to work on it and submit one, right? So you have the option between submitting that if you have not already turned it in, and remember all of the things we discussed, right? Using at least a few symbols from the flow chart, making sure it's properly formatted, presentable. You can do that, or case in point 5.2, the decision tree example, right? So it's your choice. Let's see who goes for what, okay? Any questions about, once again, anything about chapter 5, any of the case in points or assignment before we move on to the quiz portion of today's class? Yeah. So take that as a no. What I'm going to do right now is talk about your quiz and answer any questions, because the quiz is going to start in 10 minutes. Hopefully you all have access to a computer and you're able to take it. There's not going to be another chance to retake the quiz. Okay, same thing for midterm final. So make sure you plan ahead and do these things, right? Share my screen. Maybe this is the one, right? So hopefully you can see. Keep doing that. So you can see the quiz, right? So this is the quiz that you will be taking. It's going to start at 7:30, okay? You have 10 minutes to complete, okay? And it will end by 7:45. Means, you cannot start the quiz after 7:45. So the 5-minute, allowance is just in case, somebody did not start exactly at 7:30, maybe a few minutes, But once you start, it will, end in 10 minutes, okay? And some of the rules are something that you want to make sure you read, right? You're gonna have to have 10 minutes to complete. And if you want, you can refer to any books, but make sure that you're not using any kind of AI tools, right? Chat GPT, whatever. Avoid plagiarism at all costs. You don't want to do that. I see a lot of people get in trouble, right? In the university. Let's see what else. And the way this quiz is designed is it's kind of random questions, right? It's unfortunately, one person will get a different set of questions and, other person can get completely different, okay? So make sure you know that. Don't go about, thinking, oh, I'm going to talk to my friend. He answered, option A for question 1 because their question could be completely different, okay? So any questions before I take a pause and then let you guys get ready for your quiz? And I think you will get the results right away, okay? And also about next week's midterm. I think few people have asked me this. So it is going to be an in-person exam, okay? You will have to be in the class to take the exam, although it's going to be something similar, but you will have to be in attendance to take the exam. And the rules for midterm are also the same thing, right? You'll have, I think, about 1 hour, right, to complete the exam. And you can even use the prescribed book if you have it. If you want to refer to it, that's fine. But again, no use of any tools. That will be monitored. So, not being able to go to Google or whatever, right? That I will be there. But don't think that just because it's online, you can take it remotely. No, you have to be in the class, okay? So any questions about the quiz or midterm before I stop sharing my screen and let you guys get ready for the exam? Okay, if you don't have any questions, good luck for your quiz. And it should start. I mean, you should be able to get to it. Like for example, if I even go, I mean, I can't even try it, right? I'm faculty, so I can be, if I go to, to the preview, it will work for me. But if you try to start it, it probably will not work until what? 7:30 p.m. And it's going to end at 7:45. Stop sharing here. And if you have any questions, I'm here for another few minutes, okay? And after that, it's all you.
Sir, do we have to resubmit the previous week's assignment?
Well, I talked about some of the things I expect, right? If you think you have, done all of that, then you don't have to, right? If not, then you have to go back and incorporate some of the feedback I gave you. If you're interested in, getting the, good marks, but make sure that you at least, your work is presentable, right? As a team. You want to make sure that you are putting the best effort forward, okay?
Yes. Okay, Professor.
Any other questions?
Will the midterm be pen and paper or is it online?
It's going to be online, but you have to take it in class. So that's a mandatory, right? I think I have been sent a announcement thing that there will be attendance taken, okay? So make sure to be present next week. It's a 1 hour thing, so depending on few things, we may have a 1 hour class, maybe 1.5 hours, and then you will have your exam. I haven't decided that part. So I'm expecting that at the latest, we may, if we decide to do a class, right, a chapter, do maybe an hour 15, and then start around 6:45 mark, and you will have an hour. But you need to take it from the class, okay? Any other questions?
Is it MCQs or the comprehension questions?
Yeah, it's a multiple choice, but again, random questions, right? Just like quiz, it's all going to be random. Not to say that two people may not get the same question, but out of 40, what are the chance, right? Maybe 5-10% chance that some people, but the ordering, everything is decided by that system. Okay. So that's why if I were you, I would go through all the slide deck till chapter, 5, right? And make sure you really know the material and even review the book too, for some finer detail. Although it's kind of open book. If you want to use a book, that's fine, but no internet access or nothing, right? So, but again, it'll be just an extended version of the quiz that you will be taking. Okay. Hopefully that answered your question. So the quiz is now available. So hopefully you all can see it too. This thread becomes